Everybody, do you now hear me? Do you now hear me? Uh, Dear friends, I don't know what's the problem with this website now. I'm trying to fix it, but I couldn't, unfortunately, because unfortunately I can fix the slides. I don't know what's happened for the part of the slide. I can share the new one. Unfortunately, I can't end the meeting because if I end the meeting, I can't join again. Dear friends, I have sent you. If you I have sent all of the slides to you. If you check your email, now, you can download it. I have sent you the slides. You can check your email now, and you can download it. Please, please check. Please check your email. I have sent the slides to you. Operation decision making tools. Yes, yes. Please open the operational decision making tool. Please download this. Do you hear me now, sir? Do you hear me? Do you hear me? I was talking to institution about the problem. I told them I made a report and told them the problem about the slides. So okay, if you have downloaded, please let me continue the all of you have succeeded to download the slides or not? Okay. Unfortunately, some of the students cannot sign in the class, huh? That's right. Some of your friends cannot sign into class. Are you aware about that? Because one of your friends has written here, some of the students cannot sign in, but I don't know. Unfortunately, I don't know what's the problem with the Cisco. Oh, unfortunately, the problems refers to website, the Cisco. But I wrote a report and told I sent to institution. I told them the company and I told them it has problem and they are to solve it. Okay, everybody, I was talking about the problem, and I hope they solve it soon, as soon as possible. Okay, if you have downloaded the slides, please let me continue the lesson. Okay, I was talking about the essays of nature, and I told you the decision making without probability. And I told you the decision making without probability and decision making with probability. And decision making under risk. If you please look at the slide number 3. Everybody please look at the slide number 3. The decision making under risk. The probability can be assigned to the occurrence of the states of nature in the future. We can assign or we can allocate a number, a probability, for example, 2/3 or 20%, 30%, 10% to each of the states of nature in the future. When we do it, we can, by using the decision-making tools, we can solve our problem and make the best decision. And decision-making under uncertainty. Decision-making under uncertainty refers to probability cannot be assigned to the occurrence of the state of nature in the future. In the decision-making under uncertainty, we have not probability, and we should use the other tools to solve our problem or to make a decision. And as you remember, I told you, please come to slide number 4. Please come to slide number 4. You see the table, a yellow table. The essays of nature is A and B, and decisions is, for example, decision and or project are the same. Decision number 1, decision number 2, or project number 1, project number 2. In each of essays of nature, for example, in essays of nature A, in decision 1, the payoff is 1A. The payoff is the outcome of the decision. Outcome of decision is profit, for example. For example, 10,000 US dollars, 5,000 US dollars profit. This is payoff. Payoff is the result of the decisions in decision 1 in the state of nature. For example, in A is the good economical condition, B is bad economical condition. Or decision 1 is, for example, the establishing a building, a new building. Number 2 is the selling or purchasing a building. There are the different decisions, and we should, by using the decision-making tools, we should choose the best one, the best decisions to make the highest profit for the company. Okay. At first, decision-making and criteria under uncertainty. Okay. As you remember, I told you there are 5 decision-making criteria or decision-making tools under uncertainty, not under risk.
باشه. Good evening, ladies and gentlemen. I'm Khosravi. I think Mr. Mirza got some problems and he has to try again to log into the system. Just excuse us for a minute, then he's trying to log into the system. Sorry about that. Hello, can you hear me? Okay. Yes, we have to wait for Mr. Mirza to log in again to the system. Did you have any problems to log into the system tonight?
Hello everybody. Do you hear me now? Okay. I think the problem has been solved. Okay. God thanks, the problem has been solved and we can continue. I think most of the students also have succeeded to log in the class, huh? Okay. Okay. Uh, Please let me quickly continue the lessons. Okay. Uh, Everything is okay, yes? Everybody can hear me and also all of you can see the slide. Okay. Fellas, you can see the slide. All of you can see a slide. Okay. Please let's accelerate the lessons. As I told you, as you see, the essays of nature has bring in this the table, and also all of the decisions or projects that company is going to do has been written in the has been written in this table, and now we should be familiarized with the decision-making criteria. As I told you, in the uncertainty, we have the 5 tools: maximax, maximin, and the minimax regret. As you see, the 3 of them has been written here. The maximax is the choose decision with the maximum of the maximum payoffs. Maximin is the choose decision with the maximum of the minimum payoff, and the minimax regret choose decision with the minimum of the maximum regret for each alternative. Please let me give an example to you. The Howard, as I told you, the choose decisions in which decision payoffs are weighted by a coefficient of optimism, alpha. Coefficient of the optimism is a measure of a decision maker's optimism from 0 to 1. As a matter of fact, in the Howard, we assign a number between 0 to 1 to one of the each of the states of nature, and then make decisions. The equal likelihood, or the Laplace choose decision in which each state of nature is weighted equally. Okay. As you remember, I told you. Please let me pass this slide quickly because I have listened to you before. In this class, I'm going to give example to you to solve together. Okay. So I want to review it very quickly because, as I told you, in this class, I'm going to give you example to exercise in this class to write and also solve it and discuss together. In the expand, we have 3 decisions. We want to expand a factory. Company has decided to expand a factory or maintain the status quo. A status quo is the existing the situation. They maintain existing factory. It means that they don't want to expand or sell. They want to maintain the fix and use the factory again. For example, they want to renew the machines and the facility, and again to continue. And also the third decision is the sell company now. There are 2 states of nature here. If the competitive conditions, the foreign competitive conditions are good or foreign competitive conditions are poor. In each of these states of nature, each decision has its own profit for company. For example, company, the operation manager see in the expand, the good foreign competitive condition is 800,000. The poor foreign competitive condition is 500,000. Maintain a status quo is 1,300,000 or minus 150,000. If the company wants to sell now, it can sell 320,000 US dollar if the company wants to sell it now. Okay, there are 3 decisions. We want to which decision is the best for company. In the maximax solution, I told you as I told you in the maximax solutions, we should choose the maximum in each decision. For example, in expand, the maximum between 800,000 and 500,000 is 800,000. In the maintain, the 1,300,000 is the maximum. In the decision sell now, there is no difference. 320,000 is the same and is the maximum. When we choose the maximum in each decision, now the between these 3 number, we should choose the maximum of the maximum. The 1,300,000 the US dollar is the maximum between these. So in the Maximax solution or Maximax tool, tell the operation manager choose the maintain status quo, not sell, not expand. In the Maximin, at first we should select the minimum. Maximin has a composed of two words, maximum plus minimum. At first, in each decision, we should choose the minimum, and after that, we should choose the maximum. Okay. One of the students asked, what is the benefits of the choosing maximum? In this in the Maximax solution, we should choose the maximum because in this we want to choose the maximum benefits. Okay. At first, actually, very quickly we can say in the Maximax we can say the maximum number is the best solution. For example, before doing the Maximax solution, very quickly we can say the 1,300,000 US dollar is the maximum number between these, and so the best decision is to maintain a status quo. This is the benefit of the choosing maximum because we want to choose the maximum benefit in the Maximax. Okay, in the Maximin, at first we should choose the minimum, and after that we should choose the maximum. For example, if we consider the minimum one in the expand is the 500,000, in the maintain is the minus 150,000, and in the selling now is 320,000. So we choose the minimum in each X decision. Among this minimum, the maximum one is the 500,000. So the decision is expand. This is a method. This is the method of the Maximin. The Minimax direct rate solution. As I told you, in this, if you look at the slide, if you see we should focus on the state of nature. In each state of nature, for example, in good foreign competitive condition, in one column, we should choose the maximum number. The maximum number in the good foreign competitive conditions was 1,300,000 US dollar, if you remember. So we should minus, or we should reduce each of the number in each project or in each decision minus from the maximum number. So in each state of nature, the good foreign competitive conditions, the 1,300,000 is the maximum. So 1,300,000 minus 800,000 is equal 500,000. 1,300,000 minus 1,300,000 equal to 0, and 1,300,000 minus 320,000 is 980,000. And also in the poor foreign competitive conditions, we do the same. We select the maximum number in this column, that is the 500,000. So each number or each state of nature for each decision should be reduced from the maximum number. If you see, after doing this, in each decision or in each row, we should select the maximum number between 500,000 and 0 for expand. 500,000 is the maximum. Between 0 and 650,000, 650,000 is the maximum for status quo or the maintain. And in the selling, the 980,000 and 180,000, 980,000 is the maximum. When we select in a maximum number for each decision, Now we should choose the minimum. Between 500, 650, and 980, minimum one is the 500,000. So the decision making is expand. In the Howard's criteria, according to experience of the operation managers give the alpha. Alpha is the optimism coefficient, as I told you. Is the 0.3 is alpha, for example here, and also 1 minus alpha is the 0.7. For the good foreign, for the state of nature of the good foreign competitive contingents, alpha is 0.3, and for the poor foreign competitive contingents, the 1 minus alpha is 0.7. So we should multiply each of these number in each payoff, or each number in each decision. For example, in expand, we should multiply 800,000 in 0.3 plus 500 multiply 0.7 is equal 590,000. We do the same for the maintain and sell. If you see, it's very easy. So between the results, among the results, we should choose the maximum one. The maximum is the 590,000 for expand. So the decision, the Howard is the expand. In equal likelihood criteria, we should assign or allocate the same number, the equal number, to each of the states of nature. We have two states of nature here. The one divided by 2 equals the half, or 0.5. So each of the states of nature in each decision should multiply at 0.5. 0.5 can be produced the one divided by 2 produce 0.5. We should multiply each of the states of nature in each decision at 0.5, because we have two states of nature. Yes, we should choose the maximum in this method always. This is the rules. This is the principle of this method. Because it has this method has been come out, has been come out by experience of the operation managers in many years ago, and according to their experience, and also they have succeeded to extract these tools or these criteria. In the equal likelihood, so if we multiply each of the states of nature in each decision in 0.5 and produce the result, the maximum is the 650,000, if you see. So the decision is expand here. We have been familiarized with 5 methods in uncertainty, not in the risk, uncertainty situation. And if you remember, the first one told us you should select the maintain, but all of them, the rest of the methods told us the expand is the best. So we, according to 5 decision making tools, we should select the expand. So we should expand the factory and not maintain and not sell. This is the best for company. This is the best decision for company, and it can benefit to company very higher than the 2 other decisions. Now, if the risk involves in our decision, or the operation manager wants to solve the problem through the probability or risk, under risk, they should assign a probability to each of the states of nature according to his or her experience. there is a formula for the under risk for decision making under risk, as you see. The expected value equal the sigma I equal 1 to n, probability of the outcome I multiply outcome I. Outcome means result. For example, if the probability of the good firing competitive condition is 70% or 0.7, and the probability of the poor firing competitive conditions is the 0.3 or 30%. So expected value of the expand if you see, we should multiply each of the essays of nature in each decision. For example, expected value of the expand is 800 multiply 0.7 plus 500,000 multiply 0.3 equals 710,000 US dollar. For expected value of the SHS score is 1,300,000 multiply 0.7 minus 150,000 is 865,000, and also expected value of the selling decisions is can be calculated like this. It's very easy. Between the results, we should select the maximum one. The maximum one is 865,000 for maintain SHS. So the operation manager, if they consider the risk and probability, the decision tools is telling them select the maintain and not expand and not sell. Maintain and fix the current situation, the current machines and facility, and continue your production. Okay, now I want to okay. Do you see a problem here? Exercise here. And project, we have the 3 project, project 1, project 2, project 3, and situation 1, situation 2, situation 3. Okay. Have you done this exercise before or not? Okay. Okay. And now I have sent the slides to you. You have slides now in your email. You can download it. You can check your email and download it now. Okay, I have sent the slide and you can download it. Now I give you. Okay, now you can look at the slide and solve this problem. I give you 5 minutes. 5 minutes is enough because after that we should review the forecasting also. So please solve this exercise now, and after that everybody wants to discuss. I give him, or I pass him the microphone to. Yes. Right now, please. Right now, solve this problem because we want to discuss about the example now. Okay. After exercise. Okay. We can do something. We can do some things by using of the only the first three methods. Okay. Max, mean, and the regret. Only these three. Okay. And because it's very easy. Max, mean, and regret. Only these three. The hours and the equal likelihood. Do it at your home and send to me through email your results. So just now, please solve this exercise only by three methods. The first three method, okay, max, mean, and regret. Only these three, just now. Okay, very good. Yes. Anybody wants to discuss about the max? Okay, at first, let's discuss about the max. For use of the max method, which project should be selected? Mr. Riyasi, do you want to speak? Discuss for your friend?
Can you hear me, please?
Okay, please discuss. Thank you. Mr. Riyasi.
Yes, for the max formula, because the formula tells us that we have to pick up the maximum numbers or the maximum figures from each of the situations and also from each of the projects.
Very good.
So what I did, I picked up the maximum of each row. For example, in row 1, it's 23,000, 34,500, 27,000. I picked up 34,500, and I did the same for project 2 and project 3. I picked up just the maximum numbers out of each one.
Very good.
And then among these three, one of them is 34,500, the other one is 28,000, the other is 26,700. So among these three, I found out that 34,500 is the maximum figure. So this is the maximum of the maximum.
Very
That
good.
means that in the first formula, this project 1 is the 34,500. I hope I am
Very good.
correct.
Yes, very good, Mr. Qiyati. Thank you so much. Please let me explain, because some of the students haven't get the problem yet. In the max method, we should, in each row, in each project, we should select the maximum number. In the project 1, in the first row, in the project 1, the maximum number is second one, 34,500. 34,500. Okay. In the project 2, the maximum is 28,000, and in the project 3, the maximum is third one, 26,700. Among this maximum, we should select maximum of maximum. It's clear. If you see the table, you can see. Please see the table in the project 1. Project 1, the maximum number is the situation 2. 34,500. In the project 2, maximum number is the situation 2, 28,000. And in the project 3, the maximum number is the third one, 26,700. Among we have selected 3 maximum. Among these 3 maximum, we should select the maximum of maximum. This is 34,500. So we should select the project 1, because for 34,500 is related to project 1. Okay. In the maximin. Okay. In the maximin, maximin is the minimum in each situation, in each row, and then maximum of the minimum. So at first you should select the minimum in each row, and after that you should select the maximum of the minimum row. So in the maximin, which project should be selected? No. Please be careful. Please be careful. In the maximin. In the maximin. No. Maximin. At first you should select the minimum in each row, and after that select the maximum of the minimum. The maximum of the minimum. Be careful about that. In the maximin. No, no, be careful about that. In please let me go the step by step. Okay, at first, the project one. In the project one, yes, Mr. Qiyasi wrote right one. Please let me go step by step. In project one, between situation one, situation two, and situation three. Okay, in project one, which number is the minimum? Please write me in the chat. In the project one, which one is the minimum? 2003, 23,000. Yes, very good. 23,000 in the project one, in the row, the first row. Be careful and pay attention to the first row. In the project two, in the project one, if you see the project one has three numbers. Will you see all of the numbers in project one? 23,000, 34,500, and 27,000. These three numbers is for project one. The minimum number is 23,000 between these three numbers. In the project two, which number is the minimum? In project two. Yes, very good. 26,500. No. In project two, please see the project two three number. There are three numbers. Yes, very good. 26,500 is the minimum. And in the project three, in the third row, which number is the minimum? Very good. We have selected three number in each project. In each project we have one number. In the project one is 23,000. In project two we have 26,500, and in project three we have 25,400. Among these three numbers, which one is the maximum? Which one is the maximum of three number? Among three numbers, which one is the maximum? Very good. Very good. So 26,500 is related to project 2. Very good. So project 2 should be selected. It's very easy. Okay. Yes, very good. Yes, the project 2 should be selected for this side. Of course, only for the maxim-min method. In the maxim-min method, project 2 should be selected. In the maximax, the first method, the project 1 was selected. We should solve all of the five methods, and after that, we should make the decision. We should see which project has become more has been selected more than the others. Okay. At first, we should solve all of the five methods, and after that, we should choose which project has selected more than the other project in five methods. No, it was the second method. The first method was the maximax, not max. It was the second method. The third method is the regress. Okay. For the minimax regret method, the third method is the minimax regret method. Please see the slide. Please see the minimax method again. Minimax regret solution. Please look at the slide again, slide number 10, please. In the minimax regret method, if you remember, I told you in each state of nature, in each column, you should select the maximum, and after that, you should reduce each of the number in each project minus reduce from the maximum number. Okay. In each column, you should select the maximum. It's very easy. Please look at the slide now. If you look at the slide, you will find out. Okay, everybody look, please, the slide number 10, and look at it carefully. In the good foreign competitive conditions, the maximum number is the 1,300,000. In the poor foreign competitive condition, in the column of the poor foreign competitive condition, the maximum number was 500,000. Okay, please let's refer back to example. In the situation 1, or in the state of nature 1, situation and state of nature is the same, no problem. In the situation 1, please look at the column of the situation 1. Which number is the maximum? Very good, very good. Yes, exactly. 26,500. Please reduce the 26,500 from the project 1, project 2, and project 3 in the situation 1. In the situation 1, in the column 1, situation 1, the maximum number is 26,500. The maximum one. In each project, in situation 1, the numbers should be reduced from this number. For example, in the project 1, the 23,000 should be reduced from 26,500. Okay. Did you see the things that I was doing in the chat? In the first situation, in each situation, I repeat again, each situation we should select the maximum number. Okay, in the situation 1, maximum number is 26,500. After that, we should minus this maximum from each of the number in this column. For all of them, we should do the same. The 26,500 is the maximum in the situation 1. So, in the project 1, 26,500 minus 23,000 should be calculated. In the project 2 also should be calculated, and also project 3 should be calculated. 26,500 minus 25,400. And also in situation 2, we should do the same. In situation 2, the maximum number is the 34,500. Okay. In the third situation, in the third column, situation 3. Okay, situation 3 is the maximum number is the 27,600. Very good. Yes. So we should do the same. 27,600 minus 27,000 for project 1. 27,600 minus 27,600 equals 0, and third is 27,600 minus 26,700. We can calculate each of them. Okay. It's very easy. If you, it's enough you look at the slide number 10. Slide number 10 is the and as I told you, I have sent you the slides, and you can check your email and download it. Okay. I have sent to you, sorry. I have sent you the slides. You can download it and study it carefully. It's enough you look at the slides. I promise you, all of you will find out and will understand very good these methods. It's very, very easy. Okay, please let me write you the answer step by step. Okay. Situation 1. Please look at the chat. In situation 1. Situation 1, the maximum number is 26,500. So 26,500 minus 23,000. We should reduce each number in this column from the maximum. Equal yes, Mr. Riyasi, you can yes, Mr. Riyasi, please do it. And Mr. Riyasi, I want very good, very good. Mr. Riyasi, do you want to speak? Mr. Riyasi, I open microphone for you. You can speak now.
Yeah, can you hear me, please? Yeah, I mean, okay. Well, I think this is just a matter of looking at the excuse me, looking at the formula more accurately, and then it turns out to be very easy. For this method, because we are supposed to pick up the maximum of each situation first.
Very good.
For example, we have three situations: situation 1, situation 2, and situation 3. If you look at the table, first we find out what is the maximum number under each situation. For example, in situation 1, the maximum number is 26,500.
Very good.
The situation 2, the maximum number is 34,500, and then in situation 3, the maximum number is 27,600. So first we get, separate these numbers, and then under each situation we subtract or minus all of the numbers under that situation from that maximum number. For example, in the situation 1, because 26,500 was the maximum, so 26,500 minus 23,000 equal to 3,500. 26,000 minus 26,500 minus 26,500 is equal to 0. 26,500 minus 25,400 is equal to 1,100. So like this, we go for all these the situation 2 and all situation 2 like that. For example, in situation 2, 34,500 minus 34,500 is equal to 0. 34,500 minus 28,000 is equal to 6,500. So we do the same for all these situations, and then at the end we see under each situation what are the maximum figures that we obtain from this. For example, in situation 1, as it can be seen in the chat, the maximum number in P1 is 3,500. In the situation 2, the maximum number is P3, 8,500. But in situation 3, the maximum number is 900. So, which is that, yeah. So when we write P1, P2, and P3, all of them, the maximum figures, then we can check which one of these are the highest number or the maximum number of these. So in this case, P3 turns out to be 8,500. So this must be the answer.
Very good. Yes, exactly. Very, very good.
Thank you.
Thank you so much, Mr. Riyasi.
You're welcome.
For
I
your
hope I'm
complete and perfect explanation. Everybody understands? Okay, very good. Okay, very good. Two method has remained. Okay, Howard's and likelihood, equal likelihood. We have done 3 methods. Please do yourself at your home 2 other methods. Okay, 2 other methods has remained. The Howard and equal likelihood. Please do this exercise for 2 methods and select the best project by use of the 2 remaining methods, because we have not enough time now to do the 2 methods, 2 other methods. Please do yourselves at your home, and next week at the first of the class we discuss about that, and then I give you the new lesson. I think it was essential to review this. Okay, I don't know, are you satisfied with this or not? Because I thought it is essential to review this lesson again for you, because it's important. And are you satisfied with this review? Okay, very good. So next week, 2 methods has remained. We discussed about 2 methods, Howard's and the equal likelihood at first, and after that I gave you the new lesson. I will give you new new lesson. Okay, we have done 3 methods until now. Okay, maxim max, maxim mean, and maxim mean regret. 2 methods has remained, Howard's and equal likelihood. Please do yourself at home these 2 methods for uncertainty. Next week we discuss about, for this example, for this exercise, I have sent you the slide. You have, all of you have your email. Please download it. If somebody hasn't received yet the email, please reply me. Please send email to my email. This is my email. Please send to me email to send it again. Okay. Thank you so much for participating. Our time has finished, and the next class will start for other students. Have a nice time, and I hope everything's going well for you. Have a nice time, and good evening, everybody. Have a nice night. Goodbye. Okay, I'm at your service. If you have any question, please send to me email. Good night, everybody. Goodbye.